So in this practice problem, they're asking us which of the following functions grow faster. We have one function that's an exponential function and the other one that's a polynomial function. And we want to use, L'Hopital's rule. So let's look at the limit as x approaches infinity, since we're talking about these functions growing. And we are going to look at r of x over s of x, which is going to be the limit as x goes to infinity of 4 to the x plus 2 over 3x cubed plus x squared plus 5x plus 1. So if we look at this, 4 to the x, the limit as x approaches infinity of 4 to the x is going to be infinity. And then with this polynomial, as x approaches infinity, this is also infinity. So we set this up in a way that we would get the indeterminate form of infinity over infinity, because then we can apply L'Hopital's rule. So let's use L'Hopital's rule, and we'll take the derivative of the numerator. The derivative of 4 to the x is 4 to the x times the natural log of 4, and then the derivative of 2 is 0. In the denominator, we'll use the power rule. We'll get 9x squared plus 2x plus 5. But all this did was give us another indeterminate form of infinity over infinity. So let's apply L'Hopital's rule again. And the natural log of 4 is just a constant, so it's kind of hanging out in front. So we're taking the derivative of 4 to the x again, which is 4 to the x, natural log of 4, and then we still have the other natural log of 4. And in the denominator, we'll have 18x plus 2. So I can rewrite this as the limit as x approaches infinity of the natural log of 4 squared times 4 to the x over 18x plus 2. So you can see that in the numerator, that exponential function is consistently there, whereas in the denominator, our polynomial function keeps decreasing from a cubic to a quadratic to now a linear. So we still have infinity over infinity. So let's apply L'Hopital's rule one more time. And when we do that, hopefully you see a pattern here. The derivative of 4 to the x is 4 to the x ln of 4. So now I've got 3 ln of 4s. And the derivative of the denominator is 18. So now we can see that when we substitute in infinity, we're getting infinity over 18. But the point is, the question was, which one grows faster? So we can see that because the numerator is consistently staying at infinity, that's growing much faster than the polynomial in the denominator. So we would say, therefore, that r of x grows faster.